Welcome to Module 4, which is on stars. The stars are the primary way in which humans have oriented themselves in the universe as a whole. We have the sun and the moon and the stars, the larger realities of especially the nighttime world of stars. Thomas Berry has a great phrase. He says that at night we begin to perceive those realities that give birth to all of our daytime experiences. So by looking at the stars, we're contemplating the beings that enabled us to be here. Now, this wasn't exactly the way in which earlier humans thought about stars, for sure, but there was a sense of the stars of being divine, even gods. And our orientation is actually similar to that, because we're realizing that the stars are the creative centers that gave rise to us. And we'll deal with this in detail later, but I just wanted to start off with a way of remembering that the ancient fascination with stars and the valorizing them as something of supreme importance surfaces in a different way within the scientific story. Stars as progenitors. Now, one of the main differences between our perception of stars now is that the ancient peoples thought of stars as, whether or not they're divine, they thought of them as unchanging, as eternal. And so there was a sense of a separation between the starry realms and the earthly realm. Earth was a place where things changed, but the stars were the same, always, eternally the same. And we've discovered by a more careful observation that the stars themselves have an entire life cycle, the same as any animal. They're young, and they go into middle age, they go into old age, they die, and we're seeing that there's a fundamental similarity of growth and development throughout the entire universe. Stars are not different. The birth of a star, to go back to the beginning, the birth of a star begins with a great cloud of gas, and the cloud itself is very similar to the human in that it's filled with ambivalence, so that a cloud, in a certain sense, wants to come together. It has all of this gravitational attraction, which draws it together, but it also has a repelling force, or the heat. They keep the molecules of the cloud keep bouncing apart, and so you have, it's very typical in all the universe. Stars no different. You have conflicting forces, and it's in the midst of that conflict that the star has a chance of its beginning. What has to happen first, though, is that the star has to get to a place where there is more of a balance between these different forces, the forces of attraction and the forces of repulsion. And this takes place, if you imagine a cloud drifting through space. It takes place because the cloud is releasing its energy, and so it's becoming cooler, and it enters into a region that we call in complexity science a critical point, or a critical region. And it's a place where small fluctuations, small changes can be amplified and take on a larger macrocosmic role. And I just wanted to bring up that point because our situation with even in terms of ourselves as individuals, but also in terms of society, it's this question of entering into regions where a major change is possible. And so the kind of situation of a star getting into that critical region, I think, is kind of like our situation as a society as a whole. Because of all of these conflicting pressures and tensions, we're in a time when small fluctuations, which are amplified, can change the nature of the whole itself. So in the situation with a star, you have a cloud that is cooling, and it's gotten into this critical region where suddenly a small fluctuation can make all the difference. And in a galaxy like the Milky Way, the cloud itself is suffused with waves, gravitational waves that sweep through the galaxy as a whole. And these waves actually will increase the gravitational attraction. So the cloud itself is given a certain bump and pushed together. And that is just enough for the attractive powers to overcome the resistance on the part of the other molecules of gas. And so then you have this rush towards a new center. And this heats up the star, heats up the cloud enormously. It takes a long period of time, but it starts to get hot. And finally, after, depending on the size of the cloud, but you can say 10 million years, we get to a cloud with a center whose temperature has reached 10 million degrees. And it's at that point that the hydrogen atoms begin to fuse and form helium atoms in the core. So we have this nuclear fusion taking place. And now notice we had this collapse of the cloud. It's collapsing in on itself gravitationally. It's getting hotter and hotter. But then at the center, we have the emergence of a new energy from nuclear fusion. And that energy radiates out and matches the collapse of the cloud. And so you have a new dynamic equilibrium forming. But it is, if you didn't have that nuclear fusion in the center, releasing its energy, you'd have a continual collapse of the cloud. But suddenly, you have a new balance. Gravity wants to push in further. Nuclear fusion wants to push out. And so we have this new entity, this new being, the star itself. It is one of the things I love about the story of the star is that it requires a nudge from the galaxy as a whole. It requires some kind of an activation. So it's hard not to commit the crime of anthropomorphism here. So I'm going to go ahead and commit it. That we can relate to a star in this way, that the cloud itself has got these different inclinations and tensions, and then suddenly a wave comes along and pushes it just over that area of indecision into this action called a star. And I think it's the same thing for our lives. There's so many different things that we're concerned about, and yet something comes into our life, either in our family or in the national scene or even personally, and we suddenly get a sense of what really matters. And things start to organize around that. But it is a sensitivity to the currents of energy that are passing through our moment. Last comment is that I said density wave, or I said the wave of gravity passing through the cloud. That the form of that wave determines the size of the star. So it can be a huge super blue giant star, it can be a tiny brown dwarf, anything in between. It's the music of the waves themselves that determines which star and what composition, what size will be born. So there's, again, with the human situation, what we find ourselves sensitive to will determine in a real sense the kind of creativity that is drawn forth.